Hi folks, in this video we're going to look at the solutions to the Unit 5 quiz. Okay, so be sure to skip ahead if you don't need to see all the solutions, and I'll be posting the times where each question starts. Okay, so let's start with this first one. Show analytically that these 4 points form a rectangle. Okay, so a few things to keep in mind. In order to show something as a rectangle, we want to show that opposite sides are parallel, and adjacent sides, means the sides that meet at the corners, are perpendicular. And those are both things that we can determine by finding the slopes of the lines. Okay, now we assume that when it's given in alphabetical order that we're going in either clockwise or counterclockwise order. Okay, so I'm not even going to bother drawing this here. It's going to take time to draw a graph because I know I'm going to have to find all the slopes anyways. Okay, so let's start by finding the slope of AB. So y2 minus y1, 3 minus 1 over x2 minus x1, so 0 minus -1. So here we have 2 over 0 plus 1 is just 1. So here we have a slope of 2 between A and B. So let's now check between B and C. And if this is indeed a rectangle, we know that the slope should be the negative reciprocal. So let's go ahead and find that, BC. Okay, so y2 minus y1, 1 minus 3 over x2 minus x1, 4 minus 0. So notice I always have to keep the same order as I'm doing my subtraction. So here we have 1 minus 3 is -2 over 4, which is -1/2. And these are indeed negative reciprocals of each other. Okay, so it means AB and BC are perpendicular. Okay, still not done yet. So let's now look at the slope of CD. So this is adjacent to BC, opposite to AB. So we should have a slope of 2 if this is going to be a rectangle. So here, let's do the slope. So y2 minus y1, so we have -1 minus 1 over 3 minus 4. So that gives us -2 over -1, which can be simplified to 2. And yes, they are parallel, so that's good. And now let's find the last side, AD, and that should be parallel to this one here. Okay, so AD, so y2 minus y1, so -1 minus 1 over x2 minus x1, 3 minus -1. So that gives us -2 in the numerator, 3 plus 1, 4 in the denominator, and we simplify and we have -1/2. Okay, so we can say since opposite sides are parallel, okay, my symbol for parallel, and adjacent sides are perpendicular, okay, it is a rectangle. Okay, so keep in mind that when you're having to work with things that are parallel or perpendicular to each other, it's the slope that's going to help you determine those things. Okay? So now we're going to move on to number 2. Okay, so number 2, it says determine the equation of a line. So what I'm looking for is the equation of a line that is perpendicular to the line defined by this here, 4x plus 5y equals 12, and with the same x-intercept as this other line. Okay, we keep in mind that in order to find the equation of a line, I need a point and the slope. So since it's perpendicular to this line, this is the one I'm going to use to help me find the slope. So let me find, so step 1, let's find the slope of that first line. So I have 4x plus 5y equals 12, and the way to do that is to just isolate y. So 5y, bring the 4x to the other side, becomes minus 4x plus 12, and now I divide both sides by 5. So remember, I'm dividing this whole side by 5. So I get -4 over 5x plus 12 over 5. But this is the only thing I'm interested in. Okay? So the slope of this line is -4 over 5. But the line I'm looking for is perpendicular to it. So I'm actually looking for the perpendicular slope, which of course is the negative reciprocal. So it's going to become positive 5 over 4. So this is the slope that I'm going to use to find my line. Okay. Secondly, let's look for the point. And in this case here, the x-intercept of my line is the same as the x-intercept of this line here. So let's find the x-intercept of that line. And of course, what's special about an x-intercept is the y value has to be equal to 0. Okay, so I'm just going to take my equation, and wherever I see a y, replace it by 0. Okay, and so that just disappears. 3 times 0 is 0. So now I can solve for x. Negative 16 divided by 2. X equals negative 8. Okay, so that means if the x-intercept is negative 8, it means that the point negative 8, 0 is on the line that I'm looking for. So now that I have the slope and I have a point, I can find the equation, and that'll be my step 3. So let me throw everything into my equation of a line. Now, if you're comfortable using point-slope form, you're more than welcome to use that form there, but here I'll use slope-intercept form. So when y is equal to 0, okay, the slope we know has to be equal to 5 over 4. So when y is 0, x has to be equal to negative 8. And now I can solve for b. So remember, it's like 8 over 1. So before multiplying, I notice that the 8 and the 4 will reduce to 2 over 1. And so I've got 0 equals, well, 5 times negative 2 is negative 10, plus b. So b is equal to 10. Okay? And remember that what they were asking me for was the equation of this line. So my answer is going to be y equals 5 over 4x plus 10. Okay? And that satisfies all the conditions we were given. Okay, we're going to move on to number 3 now. Okay? Now notice here, I'm insisting that you use a graph. So if you were to be asked to use a graph on the test and you solved it algebraically, you wouldn't get any marks for this question here. So you have to follow what's given. So use a graph to determine the point of intersection between these two lines. And luckily we see that, well, these two lines are quite easy. Okay? So I've got y equals x plus 4. Okay, given in slope-intercept form. So I'll use the fact that the y-intercept, okay, is 4, and the slope is just the coefficient of x, is just equal to 1. Since my other equation, even though I could easily write it in slope-intercept form, excuse me, sorry about that, I'm going to find the intercepts, just as a reminder of how to do this. So if I want to find the x-intercept, I make y equal to 0. And that was nice and easy. X equals 2 is my x-intercept. And in order to find my y-intercept, I just make x 0. And so I see that my y-intercept is also 2. Okay, so now let's sketch the graph. Okay, so I want to choose my scale carefully. So my x and y intercepts are both positive, and I see that my other line starts at 4, and because the slope is 1, it's going to go upwards. Okay, so I'm actually not going to have too much on the negative side here. So I'm going to make my axes here. There's my y-axis. And here, I'll put my x-axis down here. Okay, and since the numbers are small, I'll have my scale is going up 1, 2, 3, 1, 2, 3. Okay, so let's draw the first line. So first line has a y-intercept of 4. So there's the y-intercept, and it goes up by 1. So as x goes up by 1, y goes up by 1. And so there's 1 point. Okay. So let's try to draw the line as nicely as possible. And then in my other line, we have the x and y intercept at 2 and also at 2. Okay. And now let's try to draw the line as nicely as possible. And so now it looks as though our x-intercept, or sorry, our point of intersection occurs at this point here, -1, 3. Sorry, got to take a drink of water every once in a while. So here my point of intersection is at -1, 3. So if at any point you also want to solve it algebraically to check your answer, you certainly could do that. Okay, let's move on to number 4. So here, cheap cell phone charges 25 cents per minute of use. Basic charges a flat fee of $15 plus 10 cents per minute. What advice would you give someone who's deciding which company to choose? Be specific. Okay, so here I've got two companies, okay, whose charges can be modeled by linear equations. So what I'm going to do is solve this using a system of equations, and I'm going to find when they're equal. When I know at what amount of time both charges are equal, I can then make a determination as to when one is better than the other. Okay, so let's go cheap cell phone, we'll call C. So here it just says 25 cents per minute. Okay, there's no flat rate. Okay, so depending whatever the number of minutes is, I multiply by 25 cents. Okay, so my equation is actually pretty easy because it's just 0.25x. Okay, and I'm going to give my variables where y is cost and x is time in minutes. Okay, so there's no flat fee, there's no y-intercept here. So let's remember, by the way, that this type of linear relation is called a direct variation. Not that they're asking for it, but good to review that. Okay, now basic cell phone, a little different. Okay, charges 10 cents per minute, so the rate of change is 10 cents, so 0.1x. But this one does have a flat fee or a y-intercept of 15. Okay, where y and x represent the same thing. Okay, so what I'm going to solve for is I'm going to solve for when the two plans are exactly the same. Okay, so here I'm going to do this by substitution instead of drawing a graph. Okay, so the first one tells me that y has to equal to 0.25x. So since I'm looking for the point of intersection where they're the same, this y has to have the same value. So I'm going to substitute this y with 0.25x. And now I have a nice, easy linear relation to solve. Okay, so let's bring the 0.1 to the other side. So 0.25 minus 0.1 is 0.15x equals 15. And x is equal to 15 divided by 0.15, which should be able to do in our heads, but again, especially on a test, you don't want to take any chances. Okay, so this should be 100. Let's check. 15 divided by 0.15. Whoops, I put in the wrong thing. Divided by 0.15. Let's try again, and it is indeed 100. Okay, so that means when you talk for 100 minutes, they have the exact same cost. Okay, so a couple of ways to decide which one is better at which times. So you can try to reason it out, or another thing that I showed you in class that you can think of is just draw yourself a quick graph that's not precise. So here, 0.25x I know is going to cross through the origin, so that's going to be my cheap cell phone. And the other one has a y-intercept that's not 0, but I notice that the slope is smaller than that one there, so it's going to increase more slowly. It's going to be less steep. Okay, and there's my basic, and that's where they intersect. So I can see that when I'm less than 100, cheap cell phones is going to be better because it costs less, and when I'm more than 100, basic cell phone is going to be better because it costs less. So here I can say for less than 100 minutes, choose, again, the lower one is cheap cell phone, okay, for more than 100 minutes, choose basic cell phone. Okay, and there you have it. So we're able to solve this problem without having to actually graph it accurately. Having said that, the quick graph did help us answer the question. Okay, let's move on to number 5. Okay, so here it's just solve the system of equations. Okay, so again, I could have asked this as find the point of intersection between these two lines. So again, I always have the option to graph them, but I really want to try to do this by algebraically. Okay, so let's take a look. So I'm going to call this equation 1 and equation 2. So first I look for a nice easy variable to isolate, and I see that there really isn't one. Okay, they all have coefficients other than 1 and minus 1. So I had to choose one. Well, here I got the two smaller coefficients, so I'll work with equation 1. And I might as well isolate y, because I'd rather divide by 2 than divide by 3. This is sort of a nicer to divide by 2. So I'm going to start with equation 1, and I'm going to isolate y. So first I'll bring the 3x to the other side. So 2y is going to be equal to negative 3x minus 11. And now I'll divide both sides by 2. So I have negative 3 over 2x minus 11 over 2. Okay, so the next step in the process is to substitute this into the other equation, meaning that wherever I see y, since these two y's are equivalent, wherever I see y, I'm going to replace it by that expression. So let's take equation 2, so 2x minus 6 times, instead of y, I'm going to put in negative 3 over 2x minus 11 over 2. Okay, and now I have one equation with one unknown that I can solve. So 2x, okay, so here let me distribute the 6 to both terms. So negative times negative, so that's going to become an addition. And now here the 6 and the 2 are going to reduce to 3 over 1. So I'm going to have 3 times 3, so plus 9x. Okay, similarly here, negative times negative, so that's going to become an addition, and the 6 and the 2 are going to reduce to 3, so 3 times 11 is 33. So equals negative 11. Okay, and so here, now 2x plus 9x is 11x, and let's bring the 33 to the other side, so negative 11 minus 33, so 11x is equal to, so that's going to be negative 44, and so x is equal to negative 44 over 11, so that's just equal to negative 4. Okay, so we found the first half of our solution. But of course, we also need to find the y value, because the solution to the system includes both an x and a y value. So let's now input that into any of the equations, and here, since y is already isolated, I'll use that one there. Okay, so I'm going to use this equation here to find my y. So y is equal to negative 3 over 2. Wherever I see x, I replace it by negative 4 minus 11 over 2. So here, the 2 and the 4 reduce to 2. Negative times negative is positive, so y is equal to 3 times 2 is 6 minus, well, 11 over 2 is like 5.5. So y is equal to 0.5. Okay, if that had not been a nice decimal, I would have had to leave it as a fraction, but since it was a nice decimal, I could use that. Okay, so here we go. The solution is x equals negative 4, y equals 0.5. Now remember, had they asked me for the point of intersection, I should be giving this answer as an ordered pair. Okay, so let's move on to the last question. Okay. So here, Hakeem invested $15,000. He put part of the money in a term deposit that paid 4% for the year, and the rest in treasury bill that paid 5% for the year. At the end of the first year, he received a total of $690 of interest from both investments. Okay, how much did he invest in each? Okay, so as is often the case in the question, they kind of indicate what the variables should be. Okay, how much he invested in each of those different accounts. Okay, so I'll say let X be the amount in the term deposit and Y be the amount in the treasury bill. Okay, so now what we have to do is, since we've got two unknowns, we're going to have to find two equations. Okay, so let's start with the easier one. He invested a total of $15,000. That means if I add the amount from the first investment plus the amount in the second investment, it should give me a total of $15,000. So that's equation one will be X plus Y equals 15,000. Okay, now the other piece of information they give me is about the interest that he makes. Okay, so now let me come up with an equation for the interest. Well, for the term deposit, he made 4%. So how do you find 4% of that amount? You just do 0.04 times the amount invested in the term deposit plus the second one paid 5%, which is 0.05 times the amount invested in the treasury bill. And if I take the two interests and put them together, I should get my total of 690. And here are my two equations. So here, it's really no contest. I'm definitely going to use equation one to isolate a variable. So I can choose to isolate X or Y. Might as well just isolate Y. So Y is equal to 15,000 minus X. And now step two, substitute this expression into the other equation. So I'm going to take equation 2, and wherever I see a Y, I'm going to replace it by 15,000 minus X. Okay, and now we can solve this here. Okay, so 0.04x, okay, plus, well, and let's calculate what is it? 0.05 times 15,000, okay, is 750. Okay, minus 0.05 times x, so 0.05x equals 690. Okay, so let's keep the x's on one side. 0.04 minus 0.05, that's 0.01x. And let's bring the 750 to the other side. So 690 minus 750, so 0.01x equals 690 minus 750. Well, that's just negative 60. I don't think we need the calculator for that. Okay. Okay, and our final answer will be x equals, oh, wait a minute, sorry, I just realized a little mistake here. 0.04 minus 0.05, we should have had a negative there. Okay, so just watch out. Make sure you always think about your algebra. Should be negative there, so now I'm dividing negative 60 by negative 0.01. Now, by the way, just to let you know how I knew that, is I could see that my answer was going to turn out to be negative. So that flagged to me that maybe I made a little mistake. So that's when I went back and noticed that little arithmetic error. So that's why you always have to be conscious of any little mistakes you made. So at this point here, I might as well check the 690 minus 750. Make sure, yeah, definitely is negative 60. But shouldn't take any chances. So now I have to divide that by negative 0.01. And that gives me 6,000. Okay, but now that I'm giving my answer, okay, now that I'm not sure, computer went dead. Hopefully this is still going. Now that I have my answer, I should be giving the unit. So this represents amount of money. So it's $6,000 in the term deposit account. Okay, and if I want to determine the amount in the other one, well, hey, I can use this equation, which gives me y in terms of x. So 15,000 minus x now I know is 6,000, and that's $9,000. Okay, so there we go. 6,000 in the first, 9,000 in the second. Okay.